All right, so in Module 6, we're going to add a couple of, or we're going to talk about a few minor issues or minor enhancements to some of the operators, particularly the assignment operator that we've been working with within the last few modules. Nothing that we're learning in this module fundamentally changes the way we program. And it actually does not enable us to do anything fundamentally different. It's just giving us a few shortcuts. So it's sort of an add-on to the type of syntax that we've already seen. One of the things that you're going to notice is that after a few more modules here, we're going to run into the end of a lot of the new syntax in C++. And we're going to start to see that most of the new things that you learn about C++ from CS1 or from your first course on forward is about learning how to write less or learning how to do a lot more in a lot less code. And you know, from a very simplistic point of view, the reason we want to do that is because everybody makes mistakes as they type, and it takes a certain amount of time to type. Every keystroke that we make has a certain chance of becoming an error. So to write less means ultimately to make less mistakes if we can really master the syntax. So we've already seen some shortcuts, right? We know that we can declare variables. If we're going to declare an integer variable x, y, and z, we can do it all on separate lines, or we can combine it, and we can write it all across the same line. And this is a nice example to start out with, because although we've seen it, we know that there are some rules. We can't mix and match data types. Certainly, everything that comes after this int will have to be integers. But it's a good example because it shows you, in some cases this is going to be preferred, in some cases this format would be preferred. For this situation, if all three of these variables are highly related, I'd recommend go ahead and use a shortcut. It avoids duplicating the data type for each one of them. If you want to change the data type for all of them later, it makes it a little bit more simple. You can just type double once. But this only makes sense in terms of if they're all fairly related to each other. If they're all very distinct variables, very different from each other, it might make more sense, it might be more readable and more maintainable actually to keep the long form. So one of the things I want you to remember as we continue through this module is that all the shortcuts that we see does not necessarily mean you always want to take advantage of them. It'll take some time before you develop a feel for when one's better than another, and everybody will come down on a little bit of a different side of the argument. So you'll actually see me write the long form of variable declaration much more often than I do the short form, but you might choose to do it another way, and that's fine. We've also seen printing shortcuts. Sort of implicitly, we've always used cout and strung together several different expressions. Certainly this is the more common form as opposed to printing out individual fields one at a time. And we know that we can mix and match here, right? We can print out x space y, and then on another cout statement print out space z and an endl. Again, shortcut. If some of these later on we'll learn about conditional execution, sometimes it'll be helpful to be able to separate some of these statements out. But for the most part, you'd see most people use the shortcut for cout. Following along with cout, cin certainly has some shortcuts. Rather than reading in two integers or two doubles, whatever data type this might be, in two separate cin statements, we might very well combine them and read them in this way. This is another example where the shortcut may actually be very rarely utilized. One of the downfalls or one of the side effects of using a shortcut like this is that you can't put separate prompts in between the cins like you can over here. Right? So it's not that typical, but it is sometimes useful. Where you see shorthands being most commonly used is in assignment and using operators. So first off, let's look at assigning variables to be the same value. Let's say we've got x, y, and z all already declared and are all the same data type. And for whatever reason, we want all three of these variables to become 7. We can do this by saying x equals 7, y equals 7, z equals 7, or we can just simply say x equals y equals z equals 7. This is a little, when I say it out loud left to right, that can be a little bit confusing because actually remember that assignment operators all work flowing right to left. And this might be best shown in a little small diagram. If we've got some variables, so I'm going to put 4 separate variables here. And I have x equals y equals z equals w equals 7. So I added in a 4th one there. Remember that the assignment operator executes right to left. So we actually go over here and we execute this statement. 7 is going to get copied into w. Interestingly enough, the assignment operator is actually an expression. And remember, expressions evaluate to something. They have an answer. W plus 7 would presumably have an answer. W equals 7, assign 7 into W, actually comes out to be the number that's stored in W. It's kind of counterintuitive, but it actually will help you down the road catch some mistakes later on. Now, we've got the Z equals 7. So the Z equals 7, of course, puts the 7 in here. And the result, or the expression Z equals 7, results in 7 as well. And if we continue on, we've got Y equals 7. That results in 7. And then X equals 7. Right, so the chain of execution is going to go right to left. And that number that you put in here will cascade over into all of those variables. It doesn't make a difference whether or not the rightmost side is a literal value. It could be a variable. Of course, it would work the same way. It could be an expression. This expression, W plus S, will evaluate to something, and then whatever was evaluated to would get assigned to Z. This expression would not be re-executed when we put it into Y or we put it into X. The value of Z would be W plus S, so let's say that number is 6. And then that 6, because it's in Z, will be transferred to Y and then will be transferred to X. Mathematical assignment is also very, very common. Lots of times we have a given variable and we want to change it by a particular value, but we're going to update the exact or the very same piece of memory. So writing things like x equals x plus 5 is very common. And we want to be clear that there's no real problem with having x equals x plus 5 in an assignment statement, of course assuming x already has a value in it. So if x has 10 stored in it, just because x appears on the right-hand side and the left-hand side is perfectly fine. A lot of times the first time we see this, having this variable on the same or on different sides of the equal sign gives some people some angst, because in algebra this wouldn't make any sense, right? X could not possibly equal x plus 5. But this is just an assignment, right? So the 10 plus 5 happening on the right-hand side, that'll evaluate to 15. And then as a second step, 15 will get plugged in to x. The fact that the variable x is on the right-hand side and then is on a variable on the left-hand side of that assignment operator, from C++'s point of view, is meaningless. It doesn't make a difference. All right, so rather than writing something like this, a shorthand notation is just to do x plus equals 5. And that's a pretty nice shorthand because it removes the duplication of that variable x. If you know that you want to update x and add 5 to it, it's easier. It's also safer to write it like this. You could accidentally type y here and have x equals y plus 5 instead. So just having the variable name once is a benefit. And this works for subtraction, it works for multiplication, it works for division. If we go over to programming exercise 5 we did in the previous module, this was computing dollars and cents and coin and exact change. If we look at something like amount equals amount mod 25, mod 10, mod 5, this is something that could actually be written as mod equals. And if I was writing this at the time when we've already covered combined operators, I would have done that. Certainly it would have been a little bit more convenient. Right, so that's how you would commonly see that statement. And you don't really need to comment it. It's pretty much understood, but I'll leave it there for case of example. Notice that this would not use the combined operator because the left-hand side variable is not really being updated by itself. Finally, this shorthand exists because we after years of programming, we see that we actually do these type of operations quite frequently. We update individual variables. We also tend to update or increment or decrement variables by 1 very, very commonly. And because that's so common, we've got a plus operator that will serve that purpose as well. So if we switch back over here, you want to recognize that x equals x plus 1 is perfectly fine. We could also do x plus equals 1, but far more commonly, if it's just incrementing by 1, we'll do x plus plus. X minus equals 1 will probably be written by as x minus minus. There is a difference between whether or not this is appended or prepended to the variable. And the difference most of the time does not matter. In this case, I could write x plus plus or plus plus x the same exact way. It'll have the same exact effect. However, the plus plus happens last when combined in a larger statement. So if I did C out x plus plus, let's assume x was 4. Right? When I do C out x plus plus, I will actually print out 4, and then when the C out statement is complete, x will be incremented to 5. If I do the plus plus x, that increment happens before the rest of the statements in that line. So if x initially was 4 and I did C out plus plus x, the result would be x being incremented to 5, and then the complete C out statement would be written. So if I had something like, make this a little more clear, if I have C out x plus plus, that is the same thing as saying C out x plus plus. If I have C out x minus minus, oops, sorry, not quite that, that's not what I'm going for. Let me start fresh here. If I had my x plus plus, that would be the equivalent of doing a C out operation and then incrementing. If I did C out plus plus x, that would be equivalent to doing an x plus plus and then a C out x, which would certainly give us a different result. More often than not, we will always opt to do the first version unless there is a strong reason to do the prefix style with plus plus x. And we'll use this plus plus notation quite a bit more when we start to do loops in a future module. All right, so building on a few of the problems from programming example from Module 5 and building on and utilizing some of these combined statements, Lab 3 is asking you to get from the user numbers between 0 and 1000 and compute the sum of all the digits. And actually, you can make this exclusive, so it can really be 0 through 999. So it'll be a total of 3 digits. That's the important thing to remember. I'd like you to compute the sum of all the digits, and the trick here is figuring out how to actually extract those values. Just a hint, of course, 999. If you divide by 100, you'll get 9. If you do a modulus by 100, you'll get 99, and you can sort of chain this together in a similar way as we did with the coin example, programming example number 5.